Welcome to another deep dive. This time, we're tackling the world of scientific collaboration. We're really interested in, how scientific knowledge is actually created and shared.
Yeah.
We've got a bunch of fascinating stuff to dig into today.
Yeah.
We've got some lecture notes from a course on the science of science.
Okay.
Which covers both historical trends and modern practices. So we'll be able to get a sense of, how things have changed over time.
Right.
We've also got some recent news articles about scientific publishing, which should give us some really interesting insights into, the current state of things.
For sure.
So get ready. We're going to uncover how collaboration shapes scientific progress, how it's changed over time, and what it all means for researchers today.
One of the things that's really striking is how the image of the lone scientist working in isolation,
Right.
In their lab late at night,
Yeah.
that's becoming less and less common. Teamwork is so important in science these days.
Yeah.
And that's reflected in everything from Nobel Prize winners to the way research is funded.
That's true. You don't just see 2 or 3 scientists working together anymore.
Mm-hmm.
We're talking about these huge research teams, sometimes with, dozens or even hundreds of people involved.
Yeah, it's amazing.
And these teams often span multiple universities and even countries.
It's become a global endeavor.
It really has.
Yeah.
And our sources point to some pretty compelling reasons for this shift.
Oh, yeah.
For instance, one of them mentions a Stanford study that found that collaborative projects are actually more successful when applying for grants,
Oh, wow.
bringing in more funding overall.
Makes sense. More brain power, more resources.
Right. It seems pretty clear that bringing diverse minds together leads to a greater exchange of ideas and a broader reach for findings.
Definitely. But what do you think is driving this trend beyond just the practical benefits?
That's a great question. I think it reflects a larger cultural shift towards valuing diverse perspectives in many fields.
I think you're right.
We're starting to recognize that complex problems often require interdisciplinary solutions,
Yeah.
and that no single person can be an expert in everything.
Absolutely.
It's just not possible anymore to know everything about everything.
And that's okay.
Yeah, and it actually connects to another point that our sources bring up, this idea of an impact premium associated with collaboration.
An impact premium, what's that?
So research conducted across universities,
Okay.
or even countries, tends to have a higher impact as measured by citations.
Interesting.
This suggests that the cross-pollination of ideas and expertise can lead to more groundbreaking discoveries.
Oh, I see. So it's not just about the number of people involved, but the diversity of their backgrounds and perspectives.
Yeah, exactly.
That makes a lot of sense. Do you have any specific examples of this impact premium in action?
Sure. One striking example is the Human Genome Project,
Oh, right.
a massive international collaboration that successfully mapped the entire human genome.
Yeah, that was a groundbreaking achievement.
It really was. And it wouldn't have been possible without researchers from different countries.
Each bringing their own unique expertise and resources to the table.
Exactly. So it really highlights how collaboration can amplify the impact of scientific research.
I'm convinced.
But, is there a but?
There might be a potential downside to this trend that our sources point out. It seems that elite universities tend to collaborate more amongst themselves.
I see where this is going.
Which could potentially widen the gap between them and other institutions. What are your thoughts on that?
Yeah, that's a valid concern. If the most prestigious institutions are mainly collaborating with each other, it could create a kind of echo chamber,
Right.
limiting the diversity of ideas and potentially even slowing down scientific progress in the long run.
Right.
It raises some important questions about equity in the scientific landscape and how we can ensure that research opportunities and resources are distributed more fairly. That's a really crucial point. It brings us to another key finding from our deep dive, the impact of diversity within research teams.
Okay, tell me more about that.
So our sources indicate that ethnic, age, gender, and institutional diversity all contribute positively to the quality of research.
That's fascinating. So it's not just about having a team, but about having a diverse team.
Right.
But why is diversity so crucial for scientific progress?
Well, because it fosters innovation and helps push the boundaries of scientific knowledge. When researchers from different backgrounds and with different perspectives come together, they bring a wider range of experiences, approaches, and ways of thinking to the table, right?
Makes sense.
And this can challenge existing paradigms and lead to more creative and impactful solutions.
It's like the more perspectives you have, the better you can see the whole picture.
Exactly. It's like having more lenses to look through.
I like that analogy.
So, do you have any examples of how a diverse research team led to a particularly impactful discovery?
Let me think. Oh, I know. The development of the first effective HIV/AIDS treatment is a perfect example.
Okay.
This was a global effort involving researchers from all sorts of disciplines, clinicians, virologists, immunologists, social scientists.
Wow.
They all worked together to understand the complex nature of the virus and develop effective therapies.
And it was the diversity of their perspectives and expertise that was essential to their success.
Absolutely. They wouldn't have been able to do it without that.
That's incredible. It really shows you how powerful diversity can be.
Yeah, it's inspiring. So we've talked about the rise of teamwork and the importance of diversity in research, but let's shift gears a bit and discuss something called the Matthew effect.
Okay.
Have you heard of this?
I have heard of it, but I don't know if I totally understand it.
It's this idea that in science, just like in many other areas of life, the rich get richer.
Oh, yeah, I've heard that phrase before, but what does it actually mean in a scientific context?
So basically, the Matthew effect describes this phenomenon where highly cited papers tend to attract even more citations.
Okay.
It creates a kind of snowball effect.
The more a paper is cited, the more visible it becomes, and the more likely it is to be cited again by other researchers.
Exactly. It's partly due to something called preferential attachment, where scientists are more likely to cite papers they've already encountered or that are frequently cited by others in their field.
So it's like a popularity contest for research papers. And the most popular ones keep getting more attention, regardless of whether they're truly the most groundbreaking or innovative.
That's one way to think about it. And while it makes sense that influential papers would be cited more often, it's important to recognize the potential biases this creates.
Right.
Older, well-established papers might continue to dominate a field even when newer, potentially more insightful work is available, but just hasn't had the time to gain the same level of visibility.
That's an important point. It's like those older papers have a head start. Which brings us to another fascinating point raised by our sources. The idea that truly groundbreaking papers, the ones that disrupt existing paradigms, might actually be the riskiest to pursue.
Why is that?
Well, because they challenge the status quo.
Yeah.
And they may take longer to gain recognition,
Right.
because they force the scientific community to rethink established ideas.
So it's a bit of a dilemma for researchers.
Yeah.
Do they play it safe and focus on research that builds on established knowledge?
Right.
Or do they take a leap of faith and pursue ideas that might be transformative, but also run the risk of being overlooked or even rejected?
It's a tough call.
It is. And while there's no easy answer, our sources highlight some inspiring examples of papers that manage to combine novelty with established knowledge and achieve exceptional impact.
Really?
Yeah, these papers manage to push the boundaries of their fields while still grounding their work in the existing scientific literature.
So it's about finding that sweet spot between innovation and building upon the foundation of what's already known.
You got it. And this tension between disruptive and developmental research is a key theme we'll be exploring further as we delve deeper into the world of scientific publishing.
That sounds fascinating. I can't wait to dive into that more.
Me too.
Now let's step back in time for a moment and think about how the scientific article itself has evolved.
Oh, that's a fun one.
It's come a long way from its humble beginnings
You do really have.
to the highly structured format we see today.
It's kind of amazing how much it mirrors the evolution of scientific thought itself.
Oh, in what way?
Well, early scientific articles often read more like personal narratives.
Okay.
Almost like letters between colleagues, sharing their observations and thoughts.
Interesting.
But over time, the focus shifted to a more objective and impersonal style, with a greater emphasis on data and reproducibility.
So, less eureka, I've found it,
Yeah.
and more, here's the data, see for yourself.
Exactly. It was all about making the science more rigorous and verifiable.
That makes sense. It's like comparing a casual conversation to a formal presentation.
Right.
Both have their place, but the formal presentation is really designed for clarity and impact.
Absolutely. And along with that shift in tone, there was also a move towards standardization.
Okay.
The introduction, methods, results, and discussion sections we see in most papers today,
Right.
those emerged gradually over time.
As a way to organize research findings more clearly and consistently.
Precisely. It made it much easier for other researchers to understand and evaluate the work.
So it's like scientists develop their own shorthand to communicate efficiently within their fields.
Exactly. It's a specialized language that allows for a high level of precision.
And that highlights the growing importance of science communication.
Right. Oh, absolutely.
The ability to translate those complex findings for a broader audience.
After all, scientific knowledge is most valuable when it can be shared, understood, and applied in the real world.
Couldn't agree more. Speaking of sharing knowledge, no deep dive into scientific publishing would be complete without discussing the rise of open access.
Oh, open access. It's been a game changer.
It really has. This movement aims to make scientific research freely available to everyone, breaking down the barriers of traditional subscription-based journals.
Right, because not everyone has access to those expensive journals.
Exactly. And open access has the potential to democratize knowledge and really accelerate scientific progress.
I totally agree. It levels the playing field.
Researchers in developing countries, students, even the general public can access the latest findings without being limited by paywalls.
It's amazing.
It's a powerful idea, but it hasn't been without its challenges, right?
True.
One concern raised in our sources is the issue of publication costs.
Yes.
Who pays for open access publishing, and could this create new barriers for researchers?
Yeah.
Especially those who are already under-resourced.
It's a valid concern, and it's something the scientific community is actively grappling with.
So what are some of the models being explored to make open access publishing sustainable?
Well, some journals have adopted an author pays model, where authors pay a publication fee to make their work freely available.
To cover the costs of publishing, essentially.
Exactly. Other journals rely on funding from institutions
Okay.
or philanthropic organizations.
And are there any models that don't involve fees at all?
There's growing interest in diamond open access.
Diamond open access.
Yeah, where journals are entirely free.
Wow.
For both authors and readers.
How is that even possible?
They're often supported by universities or research institutions.
Oh, that makes sense.
Yeah.
It seems like finding the right balance between accessibility and sustainability is key.
Absolutely. It's an ongoing process.
It's encouraging to see so much experimentation and innovation in this space.
It really is. The landscape of scientific publishing is changing rapidly, and it's exciting to be a part of it.
Before we move on to some of the more recent trends shaping the world of scientific publishing, I want to touch on an interesting point raised in our source, El Sistema de la Colaboración Científica, the PDF.
Okay, what's that?
It discusses the evolution of scientific collaboration from a model of brain drain to one of brain connectivity.
Oh, that's interesting. Can you elaborate on that?
Sure. In the past, talented scientists from developing countries often felt they had to move to more developed countries.
Right, to pursue better research opportunities.
Exactly. And this was seen as a loss for their home countries.
A brain drain.
Right. However, with the rise of digital communication and online collaboration tools, scientists can now maintain strong connections with their home countries.
Oh, I see. So they can access resources and collaborate with colleagues from around the world while still contributing to research and education in their home countries.
Exactly.
It's a win-win situation.
It really is. It benefits both individual scientists and the global scientific community.
That's fantastic.
So we've talked a lot about the history and current state of scientific collaboration.
Yeah.
But what about the future?
The crystal ball, huh?
What trends do you see shaping the world of scientific collaboration and publishing in the years to come?
Well, one thing that's really exciting is the growing movement towards open science.
Open science?
It goes beyond just open access publishing to encompass open data, open methodologies, and even open peer review.
So it's about making the entire research process more transparent.
Exactly.
And accessible to a wider audience.
Absolutely.
It seems like this could really accelerate scientific progress.
It has the potential to, yeah.
By allowing researchers to build on each other's work more easily.
And by fostering greater trust and collaboration.
Do you have any examples of how open science is being put into practice?
Sure. Many research funders now require grantees to make their data and methodologies publicly available.
Oh, wow.
So that other researchers can build upon their work and verify their findings.
That's amazing.
In the field of medicine, for example, sharing data on clinical trials can lead to the faster development of new treatments and therapies.
It's really incredible to think about how these practices can have such a direct impact on people's lives.
It's very powerful.
Another trend that I've been hearing a lot about is citizen science.
Yeah.
Engaging members of the public in scientific research.
It's a really exciting development.
I've seen projects where people contribute data through smartphone apps,
Right.
or participate in online experiments.
It's amazing how technology has made it easier for people to get involved.
What do you think is driving this trend?
I think there are a few factors at play.
Like what?
For one, there's a growing recognition of the valuable contributions that non-scientists can make.
They bring a different perspective.
And they can often collect data that would be difficult or impossible for scientists to gather on their own.
Right, like observations of wildlife in their backyards or patterns in their local weather. It seems like citizen science could also help bridge the gap between science and society
I agree.
by fostering greater public understanding and engagement with scientific research.
When people feel like they're part of the scientific process,
Right.
they're more likely to trust and support it.
That makes a lot of sense.
And it can lead to more informed decision-making on issues related to science and technology.
Now, I can't let you go without asking about the elephant in the room.
What's that?
Artificial intelligence.
Yes, AI,
It's already having a huge impact on so many fields.
including science.
How do you see AI shaping the future of collaboration and publishing?
Well, AI has the potential to transform many aspects of scientific work,
Like what?
from analyzing large data sets to automating tasks like literature reviews.
Wow. So it could really free up researchers to focus on more creative and strategic aspects of their work,
Exactly. AI can be a powerful tool for augmenting human intelligence.
allowing scientists to tackle even more complex and challenging problems.
But it's important to remember that AI is a tool.
Right. And its impact will depend on how we choose to use it.
There are definitely ethical considerations that we need to be mindful of,
Absolutely.
like the potential for bias in algorithms.
Or the risk of job displacement.
It's crucial to have these conversations and ensure that AI is developed and deployed in a way that benefits humanity as a whole.
I completely agree.
So as we wrap up this deep dive into the world of scientific collaboration,
Yeah.
what are some key takeaways for our listener?
I think the biggest takeaway is that collaboration is more important than ever.
It's the driving force behind scientific progress.
From the rise of large-scale research teams to the growing emphasis on open science and citizen science.
It's clear that we can achieve far more when we work together,
And as we've seen, the nature of collaboration itself is constantly evolving.
shaped by technological advancement
Cultural shifts.
and a growing recognition of the importance of diversity and inclusion.
It's an exciting time to be involved in science.
The challenges are great.
But so are the opportunities. By embracing collaboration, challenging assumptions, and staying curious,
We can continue to push the boundaries of knowledge.
and create a brighter future for all.
This deep dive has been a fascinating exploration of the ever-changing world of scientific collaboration and publishing.
We've learned about the rise of teamwork, the importance of diversity, the power of open science,
The challenges of the Matthew effect.
and the potential of new technologies like AI.
But perhaps the most important takeaway is this:
Collaboration is not just a nice to have.
it's essential.
It's the key to unlocking new discoveries and solving the world's most pressing problems.
So to our listener, I encourage you to stay curious, stay engaged, and stay connected with the scientific community.
Because the pursuit of knowledge is a journey best taken together.